Hello grade 12s, welcome to my channel and let's hope you guys are doing well. So let's just have a look at one question for now, and part of it is going to be the standard approach, part of it is going to be for enrichment purposes. Okay, so I hope you guys are preparing well for your term 1 exams. Those who are still to write maths, there's lots of videos here to use to review and revise your work. And on top of that, please exhaust most of the practice questions in your textbooks. Remember, those ones are graded from simple to advanced, so please do all of them sequentially like that so that you can see as you gain your confidence. If you've got some study guide, please do all the examples or at least all the exercises that are there as pertaining to the topics you're going to write about this month. Okay, and of course do look at some past exam question papers. Usually just look around from the recent past, maybe from say 2-3 years, and then coming towards this particular term, meaning you can look at 2023, 24, and then but look at all those examples. Also, don't fixate on the March exams. Look at, for example, even the November exams, the May, June exams. Don't leave any stone unturned. You will cry. It is very important to ensure that these marks are in the bag and for the right reasons, that you understand the work and you're comfortable with it. If not necessarily comfortable, but at least you are very familiar with it. Because term 2, this work is going to be technical. Okay, let's not waste too much time. As you can see, this was from March 2024 from the Northwest. Of course, we have done this question, but I just felt let's just revisit this question for standard approaches as well as for enrichment. So while still talking about proving identities, we know our 3-step approach. We have essentially 1, BODMAS. Okay, 2, we have factorization. And then 3, we will have identity. Can be a law, can be even just logic or formula, etc. And with factorizations, commonly we take the highest common factor. We do dots or polynomials. So polynomials, you know that we can do the bracket method, we can do groupings, we can do long divisions, lots and lots and lots of ways. In fact, everything is long division if you think about it, but in a way we have found some shorthand techniques. And then with BODMAS, as I often say, guys, this brackets of portion could essentially mean 2 things: reduction formulae versus core functions. And as I have said nicely before, that the AS portion could just simply mean special angles. I'll just say SPAs. Otherwise, BODMAS is as we know. And of course, we always try to perhaps do reverse operations as much as possible. So let's have a look at this question 6.3. Now we have to prove the identity, and obviously what we are given is 1 over cos theta minus cos theta divided by 1 plus sine theta equals tan theta. So our job is to prove the identity, and of course, guys, we always look which one is more complicated. Fractions are more complex than just that single term. So we'll write our left hand side our left hand side is essentially 1 over cos theta minus cos theta divided by 1 plus sine theta. Okay, so we can see that we have like terms literally in general. That's the AS section, addition and subtraction. So what do? We look for the LCM. So this is going to be cos theta into 1 plus sine theta. So the LCM is always the multiple of the two denominators, if this cannot accommodate that as well as itself. Okay, so it's called LCM, not LCD. Please don't say that, you will make me angry. Anyway, we take our LCM, we divide by the first denominator. The cos's essentially disappear by dividing into 1. Then we have 1 plus sine theta left. We multiply that to the numerator. We end up with 1 plus, I don't know why my sine theta wants to have a figure there, minus. Then we take our LCM, we divide by the second denominator, and these two essentially divide to 1, and only cos theta is left. We multiply to the numerator, we get cos squared theta. Okay, so we simplify the numerator a bit because the denominator has been nicely factorized literally. So we can see that cos theta and sine theta are not the same. So we will write this 1 plus sine theta minus into this using identities, which is our step 3. Can you see we just simplified here? After that, we were forced into identities. So this is 1 minus sine squared theta, okay, over cos theta into 1 plus sine theta. Okay, so we continue and break that bracket. So we're going to have 1 plus sine theta minus 1 plus sine squared theta, all divided by cos theta into 1 plus sine theta. Now we have a situation where these two take care of each other, and what do we end up with? Sine theta plus sine squared theta. Ish. Kaya kubhala inyongo wena ngigulisa. Okay, cos theta over 1 plus sine theta. Nice, we can factorize the numerator. Okay, so that is going to be sine theta. So we're taking the HCF into 1 plus sine theta, all divided by cos theta into 1 plus sine theta. Now we can see that this bracket divides that, or they two divide into 1, and we end up with sine theta over cos theta. This is essentially tan theta, which is equal to the right hand side. Okay, so guys, this was a bit of work, as you can see, but the 3-step approach always works. As you can see, we just kept using our business here. So technically we used all 3 steps because we used our addition and subtraction, which is more like terms when we want the LCM and stuff. And then after that, what did we get? We saw that identities kicked in, the square identity. So every time we do that, by the way, once we use identities, that's a mark, okay? And then we broke our bracket and we worked nicely, and then we got 2 here. when we factorized. Okay, every time we factorize, we get our stuff done. And then we ended up with sine over cos, and then we used identities yet again. So that becomes 3 marks. So I'm not too sure about the 4th mark. Where would we say it comes in? So, because the other steps are not really that important. The other steps are not that important. So we can consider this for the mark. We can consider this for the mark. We can even consider that for the mark. So the examiner may decide where this mark goes. I would feel it's more strong there. So we can say 4 marks. But as you can see, we can place those 4 marks anyway. All right. Now comes a very inquisitive student and say, what happens if I decided to take the left-hand side, the right-hand side into the left-hand side? Well, it's going to be a bit of a rough ride, but let's try it. So we still have our 6.3. So we have 1 over cos theta minus cos theta over 1 plus 1 plus sine theta is equal to the tangent of theta. Okay, so now we decided we're going to take the right hand side. Now this is a very ambitious move. Please don't do it in the exam, guys, but do it now that I've shown you how it's done. So this is tan theta, okay? Now already tan theta is an identity, so we can use our identities. This is sine theta over cos theta. Now a common metric student would get stuck because they don't know what to do from here, right? Because it's not directive anymore. So we've done more than we could. And of course, this is a mark, by the way. So you would get 1 mark if you tried it this way. Or let's assume one decided to force you this path. But I can tell you guys, in your grade 12, you will not have such a situation, okay? Because generally, you're not expected to know what to do here. So, essentially, guys, we know that in maths, we can actually multiply by 1, right? Because when we multiply by 1, we call 1 a multiplicative identity. It doesn't change the end result, essentially. That's why an identity is something that actually doesn't change the end result, so to speak. Even if you apply it, you just remain where you want to be. Now we can say, okay, let's show this. So this is sine theta. So always try to show any trick that you do in a next step rather than the end result of the first step. It's dangerous. So now we're going to choose this one strategically. So we can see that that is our target. And there's no logic that can lead us there than to force ourselves into that. Okay? Of course, when the girl doesn't want you, what do you do? Okay, when at Tinaga, we used to break the wrist, and then she would agree because of the pain. And agreement was taken seriously in the past. So you would never agree and then disagree the next day. If you've agreed, it's a done deal. Okay? So we force ourselves here again, see, pulling out. So that's the logic part. You knew that if a girl really gives you a hard time, you break her. Okay, you don't break, but you twist her wrist. And then she gives you what you want. Not necessarily give you what you want, but she actually agrees to be your girlfriend. It was never for other reasons. Please don't do it. So we can take that denominator and say, look, we can still use this. But now remember, this is effectively 1. So this is a strategy. So guys, this is the stuff that you need to understand from grade 8 already. These are things that are taught in grade 8. We were kind of missing grade 8 because of that stupid education that was strategically sent to destroy us, but luckily we escaped it anyway. Thank God our good teachers made it possible for us to escape. Otherwise, it could have been worse. So now, once we do this, guys, remember this is as good as 1, right? But that is a strategic thing using our logic. But it's not necessarily a logic, because multiplying by 1, it's nothing but an identity. You can also think of it as an identity, literally, in maths, okay? So what do we do now? The numerators multiply, so we get sine theta plus sine squared theta. I'm not going to do the brackets. I don't have time. Then here we've got cos theta into sine, into 1 plus sine theta. Now we can clearly see that, those are the denominators. And it looks like a fraction where we had it like this. And by doing the LCM, we ended up here. Now we need that technique of partial fraction decomposition. Let me try to relax. We need the partial fraction decomposition. Whatever, guys. Yo. Yabona. Partial fraction decomposition. Of course, most of you are going to hear this at N4 level at college or first year at varsity. Anyway, so this is stuff you probably don't know, but now you have seen it in the previous video. I've shown you this thing. Please learn it and be familiar with it right now, because you will cruise when you get to it, especially when you do calculus, integrations and stuff. This becomes very important. So how do we do this? We know that, okay, guys, this implies, now we're going to start a different story now, because this is hectic. This implies that we have sine theta plus sine squared theta over cos theta into 1 plus sine theta equal to some coefficient a over the first denominator plus some coefficient b over the second denominator, as would be the case when we did the LCM, as you saw here. Can you see these were separate? We simply multiplied those denominators. Now we want to reverse the situation, but there's no knowing what this coefficient must be. There's no knowing what that coefficient must be. Hence, we use this technique. Now remember, like any other fractions, we just multiply by the common denominator. I would say CD. Now, as you can see, this denominator is common to this and that, right? And itself, because it can divide itself, it can divide this, it can divide that, because they are factors to it. So we will multiply by cos theta into 1 plus sine theta, such that we get, now when we multiply here, this denominator and this, they divide to 1, so we are only left with the numerator. So we end up with just sine theta plus sine squared theta is equal to, now when we multiply here, the cos thetas divide to 1, we remain with this, and then it multiplies the numerator there. So it's going to be 1 plus sine theta plus, then we multiply by this here, the 1 plus sine theta divides to 1, we end up with just cos theta. So this is just gonna be b cos theta. All right, now remember, partial fraction decomposition has lots of techniques to consider. The issue now is that cos theta is not the same as the sines of theta. that we have. So this creates a bit of a situation for you and I, because now we may end up in trouble. You see, the sines of theta are different from that cosine of theta, essentially. So if these are not the same, the best way to go about business here is to use coefficients. Remember, if we are given 2x plus 6 is equal to, say, mx plus c, we know that the coefficient of x is that's the gradient. We also know that c is the constant, so that would be the 1. So you would conclude here that m is equal to 2 and c is plus 6. Maybe let's not even write plus 6, it's crazy. So this is the conclusion given an expression like this. So this is more like it. So we need to try and use this technique, otherwise you would end up in trouble. So again, this could be another stumbling block for many students, this position right here. They wouldn't know what to do if they didn't know this idea. So let's see. Now, we have a situation here. There are no squares on the right hand side, but there are squares on the left hand side. So we need to sort this out. So this is sine theta plus. Now we use our identities again. Sine squared is basically 1 minus cos squared theta, because we want that cos theta to come out, is equal to a plus 1 times sine theta plus b cos theta. Okay, now we break that bracket, we end up with just sine theta plus 1 minus cos squared theta equals a into 1 plus sine theta plus b cos theta. But hold on, we can see there's a square here, but we don't have a square. But again, we can also see that this is coming out, and this is actually coming out. Remember, we can actually sort this out by grouping. So this implies that we've got 1 plus sine theta. We can group this minus, instead of cos, we can write cos theta times cos theta. Rules of exponents. When you've got this, you can break it up into its factors. Equals a into 1 plus sine theta plus b cos theta. Can you see we used some laws of exponents here to try and make this very similar to that. Now you can agree with me that the coefficient of 1 plus sine theta is an invisible one. And where is that coefficient here? It's a, because it's the coefficient of 1 plus sine theta. See, when things are not the same, you use that technique. And then you can agree with me now that b here is the coefficient of cos theta, and the coefficient of cos theta here is minus cos theta. So we can do that. We can say, therefore, a is equal to 1 and b is equal to minus cos theta. We can say, therefore, we go back. Remember, what were we trying to get to? This one right here. So therefore, we know that sine theta plus sine squared theta over cos theta into 1 plus sine theta is literally equal to, maybe let's not do it there, is literally equal to, maybe let's put it nicely and say then, yeah, this is equal to, now, what did we say? A is 1. It's 1 over the first denominator, so this is cos theta, minus, because now the plus and this minus will give us a minus, cos theta over the second denominator 1 plus sine theta, which is equal to the left hand side. So the identity has been proven. So now this is where we are, guys. As you can see, this is hectic, it's busy, it's terrible, it's dangerous, but it can be done. So you will be doing these things in calculus when you get to university, when you get to N4 level of study at colleges. Anyway, guys, I just wanted to highlight the fact that it can be done if you have the three-step approach in check. But if the three-step approach is foreign language to you and you're not confident with your maths, because unfortunately, guys, most of you take these things for granted when you see them, and you get surprised when they haunt you in the future and you'll be like, yo, this thing is hard. It's not hard. Can you see? There are some common steps that you can identify. For example, look at this. That step, isn't it similar to this one? So you can see that this thing is related somewhat. It's just that the techniques to deal with the issues are a little bit strange. So that's the thing. So anyway, guys, I hope you can see. And of course, did you see that we used a square identity in this point right here? I'm just wanting to highlight these things. Can you see we used a square identity? This time we took it from cos to sine, but this time we took it back. But still we applied the square identity. There it is. We took it from sine to cosine so that we can have terms that look a bit similar. And then of course we used some laws of exponents to sort this out so that it looks similar to that, so that we could solve easily. So these are some of the things, folks, that you need to be aware of, because these kinds of tricks and techniques will take you far. And as you can see, this one is going to involve a lot more marks than the previous one. Let's just try to mark it. If we mark this, of course, whenever we use the identity, we get marks. Okay, that's a mark. Now, whenever we use some logical technique, it's always a mark. The end result is not really a big deal. Okay. Now, technically, we're using a law of partial whatever, so that should be a mark in a way. And then when we multiply by the common denominator, we're not doing anything fancy here. All right. Okay. All right. And everything that we did, okay, when we use square identities, we get a mark. When we use laws of exponents, we get a mark. And perhaps these conclusions are significant. Can you see? A whole lot of marks. And then, of course, the substitutions here. So that's good, I think. I think that's good. So can you see there's a whole lot of marks this time around? 1, 2, 3, 4, 5, 6, 7, 8. Can you see? A whole lot of marks. But again, it depends on how these kinds of questions are essentially marked at university or wherever. But I'm just trying to highlight that you can actually do the back and forth, but you need to understand your maths very strongly, and you perhaps need a bit more, because this is something that I wouldn't expect matriculants to know. But now that you know it, you can actually apply it. No one is going to kill you, but I doubt in the exams they would believe you did it by yourself without a helping hand. So be very careful. Certain things you can find by yourself for sure, but I doubt you'd be expected to deliver such a thing. Even though our memorandums, you know what I liked about our curriculum, not to say it was special to yours, but it was better in that you were allowed to solve a math problem however you were taught. It doesn't matter who taught you, as long as it is clear, because if the steps align themselves, you can see the pattern of thought. You can see the conversation the student is actually providing. trust me, even if you were copying, there's no time to copy everything, strategy, word for word, the technique. As you can see, I go about my business, implications, I still converse then, I go on and do my things. So even if you really did copy, you wouldn't have time to copy so that nobody else sees you're copying. So sometimes how you present your work, even if it's not really at the level of your study per se, because who knows, maybe you're exposed to people who are doing higher maths. Maybe one of your siblings is at college, N4, N5, N6, or is at university, and they can actually see some of the things that you do, but now they're solving it at a better level than yours. You may actually learn on that, because remember, maths does not necessarily have a level. Okay, it's all about your ability. Of course, if you surprise your markers, they will cry. But I can assure you, though, if they don't know this, they would take this for review by the examiner, the quality assurer, and whoever. And they may look at it and make a decision and say, okay, this is correct. Because if you looked at our memorandums, when we got a hold of it from our teachers, which was a very rare thing, because they would just show you and never let you take it, you would see there's a lot of techniques that you wouldn't think about. But purely because those techniques are probably not taught at our level, but they still apply at our level, because it's not really that different. So it worked. So I hope you guys can see that you need to love the subject, and you need to understand how to solve things. That 3-step approach, folks, do not think it's a fluke. That thing took me time to figure out. And I was even more, and what you call? Goodness. I was even more inspired and more inclined to use it when in 2020 I saw Mr. Armin, is it Armin? Mohammed Amin in PE. He was in PE at the NNNU. So during the COVID, I started to see a lot of YouTube videos where I hardly looked and saw the South African basic education content there before. But then those guys, when I saw him do something similar to my 3-step approach, I was like, what? I thought I was smoking ganja, thought I was smoking something. Anyway, guys, so look around as well. You'll be inspired by people around you. There's lots of YouTubers that I suppose are at the very best level, and they understand this better, and then they can teach you tricks to get stuff done. So please do practice. Try this technique as you have seen the first time around. When you see that there's some common factors or some things that don't look too different, you can actually use some critical values, if you call it. But when things look slightly different, you try to use this technique of making things look alike, or perhaps just say equating coefficients, provided the variables, whatever those variables are. Remember, a variable does not necessarily have to be x. As you can see here, the variable was 1 plus sine x. It's still a variable, because depending on the angle theta, that whole sum is going to be different at each time. So it's a variable. So don't fixate on x. Why? Remember, trigonometry is essentially algebra. Believe me when I tell you, trigonometry is essentially pure algebra. But this time we're looking at this algebra in a geometric sense. Okay? That's just the idea you need to understand. All right, guys. I know I'm gonna talk until Jesus comes back. I hope you enjoyed the last one, because yeah, the last one is the naughty one. You wouldn't see it coming, but now that you understand, I guess you have another trick in your bag of how to do partial fraction decompositions, right? So you're not limited to just one technique. At times you try to make sure you get to the point, you get to what you want. Because if you do anything the standard approach, you will actually get yourself lost into the woods and end up not knowing which routes you took, and you wouldn't know how to get back. So the most important, every route you take, you need your yardstick, your directive, which is your 3-step approach. And it also helps you to know what to do. As you could see, every time I seemingly was going to get stuck, my 3-step approach unlocked it for me. And once I unlock it, I get to solve further until I got to my answers. So I hope you guys enjoyed the video. I'll see you some other time. Goodbye.